Welcome everybody. This is the first Leverhulme Centre for Climate Change Mitigation podcast. And in this set of podcasts, we're going to reflect on our journey over the last decade in a very kind of informal, casual way with different people involved in our work. And this first one is really thinking a little bit about the context of the centre and carbon dioxide removal. And I'm very pleased to say we've got Mike Kelland, my first enhanced weathering PhD student many years ago, to come along and chat to us about it.
Thanks very much for the invite.
So Mike, let's just get the ball rolling. So can you cast your mind back 10 years and think about, you were not yet a PhD student at that point in 2015, and enhanced weathering was pretty much not on the map of anybody at all.
Yeah, I mean, carbon removal was a niche thing back in 2014, 2015, so enhanced weathering was a niche of a niche.
At that point, the world was under the illusion that it might actually reduce its emissions. And CDR technologies may not be as essential as they are now. Of course, that proved to be a mirage.
Yeah, I kind of suspected that we would still go on to make a mess of the world, so it would be job security to retrain in the carbon removal world. But yeah, that whole idea of a moral hazard has sort of gone away now, since it's abundantly clear that we have to do something about climate.
Yeah, I mean, I think maybe the social scientists might take issue with that. Some social scientists would say the moral hazard is still very much there, in that, if you start looking at the technologies that will take CO2 out of the atmosphere, it will ease the pressure on government to reduce emissions. But I think the counter argument now is, well, it's so important that we do understand which CDR techs are going to scale cost effectively. We basically need to crack on and do the research to figure out which ones are winners and losers.
That's right. We knew even less about that 10 years ago than we do now. So, for sure, enhanced weathering was barely on the radar. I think there was a viable, possible technique. It was very much a fringe geoengineering strategy, as we used to refer to.
Yeah, of course. Now it's been, geoengineering is a dirty word. It's gone on to solar radiation management. Now carbon removal is not attached to that label anymore.
Yeah, for sure. But I certainly didn't know very much about it when I first arrived here. And really the PhD was the only geoengineering carbon removal type project that interested me, and there was a lot to learn there.
So way back in 2015, we wrote our grant for Leverhulme Centre for this new competition, Leverhulme Centres, which were high-risk, high-reward centres funded over 10 years. And we were successful. And one of the first things we did was to decide to try and write a position statement on enhanced weathering as it stood then, and really trying to show that it was a sort of triple win. It could capture carbon, could improve food security, and it could restore soil health. And you were co-author of that study. I think one of the great things that you did was really analyse the chemistry of basalt versus olivine, because olivine was one of those rocks that at the time was very much touted as the rock to use for enhanced weathering.
Yeah, I kind of came to the university under the impression that the work would all be about spreading olivine, and because that's pretty much everything that had been written about enhanced weathering was this fast weathering minerals. And so I was a bit surprised by that, and I remember trying to figure out why it is that you changed tack. And the same goes for the actual deployment area. Nowadays it's all about agricultural land. Back in those days we were thinking about direct applications of rocks to the oceans, or even airdropping minerals into forestry.
That's right. And Lila had just finished writing her paper on how adding olivine or hartsbegite, tropical forests, could capture CO2. And that was never meant to be a kind of paper suggesting practical implementation. It was more, this is the theoretical maximum you could do to take CO2 out of the atmosphere. But it was a very interesting exercise to go through that set of calculations.
But something changed there, coincident with the Leverhulme grant. So I must assume that you had something to do with that the narrative was changed from ultramafic minerals, which do dissolve very fast, but they have problems associated with them.
Yeah,
Do you
the
want to talk
trace
about
metals.
that?
Yeah, the nickel and chromium is trace metal. Let's put it out there.
Also, there's a hell of a lot more basalt than there is ultramafic minerals in the world, so that made sense to me also. Switching over to basalt.
I think one of the things I realised when I was writing the grant was there was a grey literature out there on how basalt could improve yields and soils, and so when we decided to write our position paper in Nature Plants, which itself is a funny story actually, because I initially got asked to write it as a commentary for Science, and we got Jim Hansen involved for the climate angle, and Science didn't want it. So we wrote a fuller version for Nature Plants, and it's gone on to be very highly cited. And I think that was the paper that really changed the narrative from talking about olivine and forests and oceans and talking about basalt and agricultural systems.
And I'm most grateful that you gave me something to do on that. I've only been here a couple of weeks, and
So I've got a job for you, Mike.
Yeah, no, I appreciate that.
And you analysed the GeoRock database and showed that all of the basalts from the different formations had a higher phosphorus content and a higher potassium content, which are key elements important for improving crop health.
Yeah, I think also comparing it in terms of how much nickel and chromium are we going to release compared to how much carbon could we potentially remove, basalt kind of came out on top there also. So that really did crystallise for me how the Leverhulme Centre was changing the existing narrative, which was very niche. Maybe we can spread this pulverised olivine to a new framework of agricultural implementation of this technology.
I think that's what makes it attractive. Farmers are already applying crushed rock in the form of limestone to their fields. They have the infrastructure. They've damaged their soils because of the intensification of agriculture with the use of fertilisers. Here's a thing that adopts existing infrastructure, and you could improve food security and soil health and capture carbon.
I guess it was that argument that actually gripped the Leverhulme Centre to give you the grant in the first place.
I think, at that point, of course, there were, as I just said, there were few studies in the literature, but there were hardly any experiments, which is why your first set of mesocosm experiments were so important, and virtually no replicated field trials with basalt at that time.
It would have been difficult to do those kind of ambitious multi-year field trials without the Leverhulme money, right?
I think one of the huge advantages of that award is that you can set up these long-term, large-scale trials, and you don't have to keep applying for funding every 2 years. They were very patient. It took 1 or 2 years to set up the trials in these different locations around the world, and then setting up a sample pipeline and an application of basalt, all of that kind of logistical stuff takes a huge amount of effort. With a standard 3-year grant, it would be gone before you'd got your first treatment down. Whereas with a 10-year grant, you can do all of that and then still get 5 or 6 or 7 years of data. So it was really, really, really key.
And was it Energy Farm first? Was that the first Leverhulme funded?
Yeah, they were the first out of the blocks because they had. Well, there's another story there. When I was writing the grant, I was actually invited to give a talk by Steve Long at a conference in the US, and I talked a little bit about Lila's paper on enhanced weathering, and a little bit about Joe Quirk's work on mycorrhizal fungi of trees loving basalt.
Mm-hmm.
And then I said, and actually what you really want to do is do this on agricultural land. And of course Steve was in the audience and pounced on me afterwards and said, Dave, we've got this energy farm in the University of Illinois. We have it's like a working farm. It's been funded for a previous grant. We're just about to run out of funding. Come and give a seminar at the University of Illinois, and we can see if we can kind of think about funding opportunities. So I went over and gave a talk, and then this Leverhulme opportunity arose, and it was just a nice opportunity to kind of build that bridge basically and build them into the proposal.
So that predates the successful grant proposal then?
My talk in the first conference did, and then when we were putting the bid together, that was when I went over to Illinois to meet everyone and give a chat and give a lecture.
Okay. And then Malaysia was already in your mind?
So Malaysia that really came about because of Rob and Dave Edwards. So the department has a strong link to CERT, which is the Southeast Asian Rainforest Research Project, and we used to do field courses there for the students. And obviously, thinking about the kinetics of weathering faster in tropical conditions, it seems a very obvious thing to do. So Rob and Dave lobbied me to have oil palm involved in the bid. And again, we had the right contacts with SERP and Wilmar. And so the opportunity was there. It's the right climate, controversial crop, obviously oil palm. Could we capture carbon? Could we increase yields? Very much an unknown at that point. But again, the Leverhulme Centre backed us to do the trials. And then, I suppose just to round it out, the third one was at sugarcane in Australia with Paul Nelson and Michael Bird. And those were our kind of 3 international sites. And the idea was that we've got 3 crops with large geographical coverage, so potentially large carbon dioxide removal capacity. Although, nobody really knew at this point. Very much the unknown.
Do you want to talk a bit about the team that you basically put together to build the proposal for Leverhulme Centre?
Sure. So we pulled in Steve and Evan from the Energy Farm, and then we pulled in Michael and Paul for sugarcane, and Rob, Dave Edwards, and Glenn Reynolds for the oil palm stuff. But then we also had to think about how do we do social sciences and stuff. How do we bring in the social scientists? Is it going to be? It's one thing to do field trials. If you showed it worked, to knock it out of the park, exciting results. Is it going to be acceptable to society? And of course, the leading expert at that time was Nick Pigeon in Cardiff. I didn't really know Nick. It was a bit of a punt, and I think Nick was a bit reticent about getting drawn into it all over again because he'd just done the whole, gene editing, and then what was the other thing he was involved in?
Oh, I'd read a lot of his work prior to 2015.
Yeah.
On, geoengineering.
Yeah.
He did a lot on the
solar radiation management.
Spraying sulfuric acid into the stratosphere, and the morals of that. So he was very active in the climate engineering world for sure.
I mean, the classic example of that is I don't know if we should put this on a podcast, but some scientists had got funded by UKRI to do a solar radiation management experiment.
Was this the balloon?
That's it. They had a tethered balloon. They were injecting nothing more innocuous than water vapor into the high up into the atmosphere, and then it all blew up in their faces because it turned out that Greenpeace or one of those environmental groups discovered that one of the scientists had a patent pending on the nozzle that was being used in this, and went absolutely ballistic. It was all across the front page of the Guardian. Scientists want to change the world, and they've got a vested interest in it because they're going to make money out of it, and the whole thing collapsed. Spice, I think it was called. The project,
that's right. It was Spice. Yeah.
But then there was a recent one actually, another example of where you've got to get your social scientists on board properly, right ahead of the game.
It's in Cornwall, you're talking about.
Yeah, in Cornwall. Do you know about Cornwall, the Cornwall one?
Yeah. It's worth going over because I think it's a great example, and it's a mineral weathering example.
Tell us about the Cornwall.
What they're called Planetary now. I think they used to be called Planetary Hydrogen. Planetary had decided to do a deployment in St Ives, right? I think it's right. In the Bay of St Ives, which is a beautiful bay. If you've ever been there, it's a lovely place. I think they may have done limited interactions with locals to explain what was happening, not a great deal, but ultimately went on to deploy a fast weathering hydroxide mineral, I think, pretty much directly into the bay there. I don't know exactly how, through the water courses or directly into the water, but the end result is that they were pretty much run out of town by the locals. When they determined that this was happening in their bay, they took offence to that, and I don't know what bit they were most annoyed about, but the end result was they don't want them to come back.
yeah, both those are great examples of why you need to get social scientists involved to understand prevailing public opinion and what the red lines are. So we got Nick involved, and from there, it's been absolutely brilliant to have him involved. I've learned a lot about social sciences that I never knew before.
The question that I had earlier was not so much about the academic team that you put together to do the trials. It was more about the question I had was more about the academic team, like Jonathan Leake, that you put together to actually write the proposal and develop the ideas ahead of time. That's part of the origin story as well. So you had Jonathan Leake.
Oh yeah, actually,
Steve
should really mention Steve Banwart.
Yeah.
Steve was great. For those of you who don't know, he sadly died at Christmas 2024. Yeah, it was really sad, very suddenly. But he was amazing geochemist, and but also superb editor. I've never known anyone like it. He could sit down with my text, which I think it's pretty good. Not to blow my own trumpet. He could sit down with my text on track changes, and we'd sit in my office and he'd polish it, and it would be. This is before the advent of AI and Gemini to polish it for you. And Steve was just incredible, and there were chunks of the text that we used to sit and work on in my office, and really hone it and polish it. And the other person we should mention as well that was instrumental in improving the final draft was Sean Quegan, who's a professor of maths, and Sean was very incisive in spotting gaps in the argument where the argument's not joined up, or where you need to think more carefully about, if this doesn't work, what's plan B, or how are you going to do this, how are you going to do that, challenging us to think about how to write it better. So I think Steve, Jonathan as well to some extent, and Sean were very, very instrumental in helping us develop a good proposal. And then, of course, when we went, we had an interview in the trust, as all of the Leverhulme Centre applications do that are shortlisted. So I went along with Steve Banwart, Jonathan, Nick Pigeon, and Steve Long came over from the States. And I had to give a 10-minute presentation. It had to be exactly 10 minutes. And they said to me, if you go over, we're going to cut you off. And anyway, we got off with a relatively light grilling. And we all piled in the pub afterwards, drinking some beers to relax. And we couldn't work out whether they decided, there's no way we're going to find this, it's way too crazy, we just won't bother grilling them too heavily, or whether they've given us a light grilling because they decided they like it and they were going to take a punt on us. And in the end, I remember quite distinctly, I got dragged Christmas shopping, and I got this email from the Leverhulme Trust. I was like, oh, I wonder what this is. And I opened it with a very old school Nokia phone like 10 years ago, and it opened and it said we've got this grant. I was like, I've got to go to the pub and celebrate. Sod the shopping. So off we went straight to the pub, and then of course I had to tell everybody, and had to go and see the Vice Chancellor, get a pat on the back. And then so there's that period of when as other people have experienced, when you've got a big award, there's that phase of elation, followed by that phase of, oh my God, now we've got to deliver on it. The journey has only just begun. So it's like, I've had that a few times with big awards. You get that initial endorphin hit, and then the sinking realization of the challenge ahead. But actually, it was all good in the end. We can talk more about that on a different segment.
But I guess a lot changed, didn't it? I knew that something was going to change when I heard the news. There's a lot of research going on in your group already, but this kind of provided certainty about the direction of your group's research.
Yeah, it's game changing.
And
as
and
scientists, but also for the science itself and the social science. Yeah. So thanks very much, Mike, for joining me with this podcast. It's been great talking to you. And I think your PhD was actually one of the game changing studies. I think the Kelland et al. Global Change Biology, because it showed you could get yield increases with basalt. It showed you could get CDR. It showed how you can use lithium and strontium isotopes in a mesocosm to characterize weathering. So it was another really ace paper actually, and a major contribution to the whole field.
Well, I'm still dining out on it today.
I'm very pleased to hear it.
No, thanks very much.
So next up, I think we're going to have a chat with Lila, one of the Centre's leading geochemical modelers, that's helped us take it to the whole next level in terms of modelling how these rocks, how they affect the soils, and how they capture carbon dioxide.